Hi everyone, I am Sridevi, Professor of Department of ECE. In this video lecture, we are going to learn about pulse amplitude modulation along with pulse width modulation and time division multiplexing. On completion of this course, the learners can able to understand about multiplexing and time division multiplexing, also the application of time division multiplexing. Initially, we will know about what is the concept of multiplexing. Multiplexing is nothing but giving different more than one signals through a single medium, and it can be obtained at the receiver side. In the receiver side, it will be separated. This is the concept of multiplexing. That is, simply we can tell us the signals from different channels are transmitted over a common transmission line. The time spacing between the samples of one channel is occupied by the another channels. This is the basic concept of multiplexing. It is to improve the utilization of the channel. The main use of time division multiplexing is used to improve the utilization of the channel. This TDM, time division multiplexing, can also be called as TDM. So we have analog TDM. In this diagram, sender 1, sender 2, etc. up to sender n are there. More than one sender should be there at the input side, and it will this all senders will share a single medium, that is in between the multiplexer and demultiplexer. At the demultiplexer side, the sender 1 information will be received by receiver 1, and sender 2 will be received by receiver 2, and etc. up to sender n will be received by receiver n. The concept multiplexing, this is a technique by which multiple data signals can be transmitted over a common channel in different time slots. This is called as time division multiplexing. It also allows the division of overall time into different time slots. So in analog time division multiplexing, here different time slots are there. X1 of let the signals be x1 of t, x2 of t, x3 of t, etc. of t. N number of signals are there, xn of t. So this will share a single channel. So in time division multiplexing, the complete signal gets transmitted by occupying different time slots. So this is the main principle used in time division multiplexing. So here multiplexing is otherwise called as MUX. That is the method by which multiple analog signals are combined into one single channel. So here it uses a low pass filter. Each channel should be transmitted and is passed through a low pass filter. The outputs of the low pass filter are connected to the rotating sampling switch, and this switch will be rotating, and each and every time the channel which is used to be shared is selected by this switch. So simply this multiplexing TDM is classified as different types. So this is basically from the topic multiplexing. So first is space division, second one is frequency division, third is time division, and fourth one is code division. So time division multiplexing is the method of transmitting and receiving independent signals over a common signal path by means of synchronized switches. So the switches will be rotating, so that it is called as rotating switch. So this method transmits different signals with different time slots through a single media. So here time division multiplexing is needed, so to reduce the bandwidth, so that because this signal different signals occupies a single channel, so transmitting one or more signals simultaneously can be accomplished by TDM process. So a single cable or radio link can be enough to handle this multiplexing. So this multiplexing permits hundreds or even thousands of signals can be combined through a single channel or single medium, so that the cost can be saved. So here the multiple input signals, it is given as the multiplexer. So after multiplexing, all the different n number of inputs will be converted, or it is sent through a single line. The demultiplexer will receive all the combined inputs in a single line, and it will separate this into original signals. So multiplexer or mux combines all inputs into a single signal, and demultiplexer or demux that process the input signal by sorting this received signal into different ways. So the slot diagram will be like this. Let us consider 4 inputs at the input side. These 4 inputs will be divided into different time slots A, B, C, D. Again it will be repeated A, B, C, D, and each transmitter will transmit the signal, and it should wait till its next turn. So once A is received, and it should wait for B, C, D to choose their respective slots. After D has chosen its respective slot, again the A will get its turn. Similarly, all the input signals will use the whole channel into different separate slots, and receiver side demultiplexer, it will receive the signals, that is composite signals, and it will separate that composite signal into the particular given input signal. So here, as we said, time division multiplexing, it is different. It will be yes, method that is used for saving the bandwidth, so that it will the system cost will be reduced. So as we said, the low pass filter and the switch pulse modulator, then through this communication channel pulse demodulator, and this using again the low pass filter, the input signal which is sent through the multiplexer will be received by the demultiplexer and separated as the receiver side. This is a simple block diagram of the multiplexers, time division multiplexing. Mainly it is used in system low pass filters, that is basically anti-aliasing filters are used here to separate the signals. So time division multiplexing uses pulse amplitude modulation techniques. So here at the beginning, the system consists of multiple low pass filter depending on the number of data inputs. So basic concept of multiplexer is using n number of signals by using the switch which is called as commutator. This commutator rotates and it will choose the signal which is selected by the various time slots. Here the time slots that is related with the switch selection. So according to the commutator's rotation, these time slots will be chosen. So here the maximum frequency is Fm, and here for sampling Fs should be always greater than or equal to 2 Fm, and time is Ts is equal to 1 by Fs, so Ts is less than or equal to 1 by 2 Fm. This is the basic concept used in time division multiplexing, and the pulse frequency will be 1 by Ts, that is n Fs. So implementation of TDM, it will be in two types, that is synchronous TDM and another one is asynchronous TDM. So here R is nothing but the rate signaling rate, that R is equal to n into Fs. Here n is number of slots used, and here simple basic block diagram as we discussed earlier. This time division multiplexing, here frames, different frames will be slotted. If here synchronous TDM and asynchronous TDM, two types are there. In synchronous TDM, the frames are chosen in a synchronous manner, or the order will be repeatedly same order, but in asynchronous order it cannot be predicted. So here the signaling rate R should be greater than or equal to n into Fm, and Ts is less than or equal to 1 by 2 Fm. So time division multiplexing, the bandwidth is calculated by 1 by 2 into n Fs. So the bandwidth can be saved, and this signal can be traveled in a single channel. So advantage, while talking about the advantage, it is very simple, and less bandwidth is used, and drawback or disadvantages. Here the synchronization is needed. Transmitting and receiving section must be properly synchronized to transmit and receive the signals in a proper manner. So slow narrowband fading can be wipe out all the TDM channels. That is the main drawback of the TDM, and application is TDM that is mainly used in digital communication system or cellular radio or in satellite communication system. That is the main advantage of TDM. So here we have one quiz question, that is which are non-orthogonal multiplexing. We know that another one multiplexing method, that is frequency division multiplexing, same as time division multiplexing. Frequency division multiplexing is also orthogonal multiplexing. So TDM and FDM both are orthogonal multiplexing. So C is the correct answer. That's all about time division multiplexing. Thank you.